Hello everyone, welcome to the Cloud Careers YouTube channel. This is the session 6 of our free Linux training sessions as a part of the DevOps career, DevOps roadmap. So as a part of this session, I would like to give a quick recap on what's being covered in the previous session. Previous session, we have seen how to display the content in a file using tail, head, and cat commands. We also seen how to do the advanced filtering by using sed and cut commands. So those are the things we have seen. Today, I would like to show you the file structure and how directories are organized in Linux. If you are coming from the Windows background, how Windows file structure and how Linux file structure organized are 100% different. Now I would like to show you how things are organized. So my topic for current session is directory structure in Linux and process management if possible, and then followed by the file editor in Linux. Okay, let's try to start. For example, if you are talking about Windows, how things are organized. You have a big disk, which is nothing but one big disk, and that disk will be of let's assume you're having 500 GB disk. To keep things simple, typically it will be 512, but to keep things simple, you have 500 GB disk. Fine. So you can use the entire disk as a single unit. But what we end up doing, if you are from the college background, what we do is we try to partition the disk, some portion of the disk to something called a C drive. So we're gonna give C drive, right? So we're gonna name it as a C drive, and you typically on C drive you end up only having only the installations of softwares or the components or the files that are related to system will be placed inside this. Again, you can create one more directory called as, for example, you have created 200 GB disk for your operating system or the software installations. You're a college guy, so you want to store all your college information inside a D drive, and you have given for a D drive, you have given 150 GB of disk, and you are a big Marvel fan, so you want to store all your films, all your interesting content, your media, everything on the top of another drive called as entertainment drive, where you name it, and you name it as E drive, and E drive you have allocated 150 GB of disk. Okay, this is how we organize the things in Windows. That means there is no relation between C drive to D drive and D drive to E drive. If you want to format your D drive, you can just format this. If you want to delete your content that is present in C drive, you can just delete the content that is present in C drive, right? That means once you do a partitioning, which is nothing but cutting down the pieces of your disk logically, okay, there is no relation between the C drive and D drive or D drive to E drive, right? But in Linux, it's not like that. Linux follows a structure called as root structure. Okay, so let's try to understand what is that root structure. In order to understand the root structure, you need to understand how things are organized. For example, in Linux, Linux starts everything under a root directory. Just like for a tree or a plant, what is the initial part of your plant or a tree? Root, right? So if you cut down the root, the entire tree falls down, right? So tree with roots, let's see. So just like this example, if you see a tree with roots, root is the important thing, and the entire tree is dependent on this root, right? That means the leaves, branches, everything is under the root, right? Similarly, with that context only, they exactly meant by root. And usually root is shown by using a forward slash, and this is the root directory. And whatever the content that you see will be under the root directory. For example, you see this, right? Slash. Inside the root directory, you have home, and inside that you have created another directory called as CentOS, right? And you can create all the files that are inside CentOS. And next, you can also have another directory called as etc directory, where all the system configuration related information is available inside that. You can also create all the sbin. Sbin is another directory inside the root directory, which contains all the root related commands, right? This is how things are organized. For example, no one have permission to delete the root content, to delete the content that is available inside the etc directory, right? If you delete this, system will work or not secondary. Okay, again, you can also delete this independently, right? But at the same time, if you have the authority, if you are a root user, you also have the power to delete this root directory. If you delete this root directory, you are killing the entire system. And that's the reason access to root user should not be given to anyone. Okay, access delegation is very, very important. Access delegation is something I would like to talk in the upcoming session, because I would like to show you how to create a user account, how to delegate permission, what is sudo, all these things I would like to talk in tomorrow's session. But I would like to show how files are organized. Each and every file that you create, each and every file that you create will have some specific meaning. So let's try to understand that. So directory structure in Linux. Let's try to see some nice images. And if you come here and if you see any of the image, so this is my favorite image all time. Copy this image and paste it here. So this is how the directory structure in Linux. This is how files, or each and every directory has a specific use case. Okay, is it clear? Perfect. So as I said, root is the main directory which contains almost all the content of your machine. Not almost all, every content of your machine. Okay. Now, for example, if you, what is this bin? What is this boot? What is this OPT? What is this root? What exactly it is? Okay. Inside the root directory, you have etc directory, and inside the root directory, you also have user directory, and inside the user directory, you have another directory called as bin include. Technically, these are called as subdirectories. Now, each and every directory has a specific purpose. Okay, each and every directory has a specific purpose. Bin. So each and every directory stores a content that is related to a specific job. Okay, so bin is a directory that contains the executables. For example, if you consider this bin, this contains all the files or the executable files of many basic shell commands like the ls command, cp command, cd command. All the basic commands that we use on your machine will be residing inside that. And what is this boot, or what is this etc? Etc is something which you are very much well aware. Etc is a directory which contains all the system configuration related. Okay, this is the directory which contains the core configuration of your system. Okay, and usually only the system administrators or only the users with the root level permission can have access to it. Okay, now what's next? What is this dev directory? Dev is a directory which shows you the list of all the available disks that are connected. That means this is the directory structure contains this, the files that are present inside the dev are special files, including the devices that are connected to the device. For example, it may be a file or a virtual file or a physical disk or whatsoever it may be. Okay, so all these things are connected inside that. Okay, now what is this user directory? Okay, or what is this opt directory? All the optical devices that are connected are available inside the opt directory. And home, all the user accounts that are created inside the machine will have their own home directory, right? Home is the home directory of all the users, and it is where we are going to store all the user personal data. And lib is a library. All the libraries that are related to system will be stored here. So library is basically a code which is used by the binaries or executable binaries. So usually the lib directory holds the libraries that are needed by the programs that are available in bin and sbin. And sbin is a very powerful directory. Sbin stands for system bin. Okay, sbin stands for system bin or system binary. This is a very powerful directory. So this is similar to binary directory. The only difference between the binary directory and the sbin directory is, so binary directory sbin directory contains only the commands and the files that are used by the root user or by the sudo user. What is a sudo? We'll talk about in the upcoming session. So sbin is a system binary that contains all the binaries or the commands that are used by the root user. Okay, and next, /tmp stands for temporary directory. Whatever you store inside the directory /tmp, as soon as you sign off from it, the content that is stored inside it will be vaporized. Then what is this boot directory, which we haven't discussed? So boot is a directory. It's a very important directory that contains the files of your kernel and the boot image. Okay, boot image is nothing but your operating system image. Kernel is nothing but the first piece of your operating system which directly interacts with your machine's firmware or the machine's hardware. Okay, so this is a very important directory, by the way. And the next thing is what is that? Mount. All the system devices that are connected, all the devices that are mounted will be shown here. Okay, so root/root is the home directory of the root user. So for root is the super user, we already know, just like in Windows how we have an administrator. Similarly in Windows, we have administrator, right? In Linux, root is a super user. He can literally do anything, and he's a boss in the system. And for root user, you don't have his home directory as home root. That is incorrect. So you don't have the home directory as /root. Okay, a lot of people will think that, but that is 100% inaccurate. The home directory of the root user is /root. All the content of the root user is saved inside the /root directory. All right, so yeah, that's it. And media is something, it's a mount point for the removable devices like the pen drives or the USB flash drives that you connect will be shown up here. And SRV stands for service data. So whatever the service data that you want to see will be seen up here. So it contains the data for services that are provided by the system. So whenever you're running any sort of services or web app servers, it's a good practice to store the web application data inside this. If you don't understand SRV for now, that's 100% fine. Okay, this is how things are organized. Okay, so yeah, this is a very famous image that I'm gonna paste. So let me try to paste that image. This is a handbook you can consider. So scroll down. You can use it. This is a very important thing. You can use it. I have an image. Okay, this is a very nice image. I'm gonna attach it, the link of it in the description. So whatever I discussed, you can memorize it by using this handbook. Okay, so what testbin does, what etc does, what dev does, what proc does, what emp does, all these things can be seen inside the directory. Now you would have got a better image what each and every directory does. Each and every directory has a specific job, so we need to understand that. All right, that's it. Now we know how to connect and how to see the list of directories and what each and every directory does. Okay, we are good with that. So what's next? All right, now how can I see the list of process that are running inside a machine? If it is Windows, you just click on the Windows button and you say Windows Task Manager. It's going to show you the list of available tasks that are running on the machine. And if any of the process is running a lot of amount of memory, or if it is consuming higher amount of CPU, what is the disk utilization? You can open the Task Manager and you can see the list of all the tasks along with the process utilization, right? And this is called as process and the utilization. Similarly, in Linux also, if you want to see the utilization of your Linux machine, the command to do that is next. The command to do that is top. Top is a very powerful command. It is like a task manager in Linux, which is going to show you the list of tasks that are running on your machine along with the process utilization. It is also going to show you what is the process it is running and what is the command it is executing, how long it is running. So top is a very powerful and interactive command. Okay, so it's not an interactive command, by the way. If you run something, unless until you exit from here, it's gonna show you. Okay, so it shows the CPU utilization is 0.0%, and it's showing the idle is 100% of the CPU is idle, and how much amount of memory is allocated, and out of which how much is free and how much is available. Yesterday, I have asked you a question. What is the difference between the available memory and the free memory? So please ensure if you, there's an assignment for you guys. If you know the difference between available memory and the free memory in the system, please try to understand, please try to write the summary inside the comment section. And I'll try to correct you if it is wrong, but consider that as an assignment. And this is a single command which shows you a lot of information. And if you are applying for any junior roles like 2 years, 3 years role, so in any cloud interview or DevOps interview, they'll ask you what is load average. We'll talk about it at the end of the session. And if you fail to respond, or if you fail to answer, or if you answered incorrectly about the load average of your Linux machine, the probability of your selection in the interview is very less, because if you don't know what load average is, that means you can be considered easily as a beginner in Linux. Okay, because this is fundamentally very important that we need to understand it. Okay, let's try to understand. Each and every process that is running in your Linux machine will have an identifier called as process ID, and it's also called as PID. Okay, so that is very important. Just like how you get an employee ID when you join any company, similarly, each and every process that is running in the Linux machine will have an identifier, and that identifier is referred as PID. Great. Now you can also see how much percentage of CPU is allocated, and how much is used, how much percent of CPU is being used by this particular top command, and what is the memory used by this top command, and what is the command that it is being executing, and along with since when the machine is up. Okay, means when the command is executing. This command is executed from last 3.42 seconds. And the beauty of top command is every time you don't have to refresh, and for every 3 seconds, top is going to be refreshed. Okay, so if you want to kill any process, you can use a command called as kill, and you can use the process ID. Kill process ID is going to kill the particular process. Okay, how do you forcefully kill a process? How do you kill a process in Linux? This is how you can deal. Okay, so for example, if you want to kill any process, and killing a process needs a lot of homework before you do that, because you cannot straight away go ahead and delete or kill anything in the machine. Whenever your system fails to respond, or whenever the performance on the system is very bad, then you execute the top command, you identify the list of processes that are taking higher amount of CPU memory, then you need to reach out to the appropriate team, and then based on their suggestions, you need to act on the machine. But your primary job is always you need to ensure your Linux machine should never go down. Okay, so kill is a command, process ID. Okay, this is going to kill the process. And you can also use kill. It has a signal called as -9. Sometimes you don't get an opportunity to kill some specific process. If there are some stubborn process, there are some strong process which cannot be deleted directly. At the time, you can use a flag called as -n. -n is a flag which is going to ensure it is going to kill the process very forcefully, but it will have some negative impact when you do that. So think twice before you kill any process. Okay, and next important thing, what is load average? Let's understand this. Okay, Linux is the only machine which gives you the concept of load average. Let's try to understand it. What is this load average and why it is very important? Okay, just by looking at this metric, I can see the health of your machine. Okay, I can see the health of your machine. So whenever if someone complains that the machine is not performing well, or the machine performance is not up to the mark, this is the first metric I'll come and check. What is the average utilization of your CPU in last 1 minute, last 15th minute, and last 15th minute, 1, 5, and 15th. All right. This is a very important. So this is something which determines what is the average utilization of CPU on last 1 minute, and last 50th minute, and last 15th minute. Okay, so 1, 5, and 15th. Okay, the first value depicts the average load on the CPU from the last 1 minute. What is the utilization of your CPU, or the number of CPUs? Your machine can have one CPU or two CPU or three CPUs. What is the average utilization of the CPUs from the last 1 minute? And the second value depicts what is the utilization of the CPU in the last 5 minutes. Okay, the second gives us the average load on the machine for the last 5 minute interval, and the third value gives, okay, and the third value gives the load average, okay, of the last 15 minutes. Okay, third value gives us the 15-minute load average. Okay, last 1 minute load average, last 5 minutes load average, and last 15 minutes load average. Okay, if you see any of the value greater than 1, that means it is experiencing beyond 100% of the CPU utilization. For example, if you see the value as 1.9, that means it is experiencing 190% of load. That means if it is able to pick up 100%, but the system is right now having 190% of load. Okay, if any value which is above 1% is considered as unhealthy. Okay, so if you see any of the value here greater than 1, that means your system would have experienced or is experiencing, okay, system performance issue due to the higher CPU utilization. This helps us to get a idea, a better picture of how the CPU is utilized by the process that are running on the system over the time. Okay, while 1 means 100% of the overall utilization, and if you see 0.5, that means it's 50% utilization. If you see 1.5, it means 150% of the utilization. Okay, so this is how, this is very important, and try to give the best possible answer when someone asks you in the interview. All right, this is one thing that is very, very important. And you get a lot of other information as well: CPU utilization, memory utilization, how many processes are running. The machine is up from last last 2 hours for 10 minutes, and you can also see the number of processes that are, number of users that are connected. For example, I'll duplicate the session, which is going to open one more interactive session. You can come here and see the number of users connected is 2. Okay, this is very important and very nice thing about top. Okay, so you can also get the similar option from a command called as uptime. Uptime is a command which helps you in determining since when the machine is up. You can see that the machine is up from last 2 hours 15 minutes. Okay, and the number of users connected to the machine is 2, and the load average is also this much. Okay, you can also see the load average from this command. All right, that's it. That's about the load average. You can also see the number of processes that are running by using another command called as PS. But PS is a interactive command, and the output that you get is, for example, if you hit the command at 4 o'clock 10th minute 10 second, the output that you get is 4 o'clock 10th minute 10 second. Okay, but it is not dynamic result, while top is a dynamic result. All right, guys. So PS is not an interactive, but the result, as I mentioned, is static and only for that particular session. If you just hit PS, okay, this is going to show you the things that are related to only to this particular session. Okay, so PS has a lot of options. Okay, so man PS, it has a lot of options available, and among all, to see the list of all the process that are using standard syntax, you can use PS-EF, or all 3 of them does the same thing. So if you want to see the list of process that are attached to the terminal, you can use PS-AXU. So likewise, there are a lot of options available. So let's try to see PS-EF. This is going to show you the list of all the process that are running in this system. Shows every process running in the system. Okay, next thing. So for example, this is also very commonly asked interview question. If you want to see the list of all the process that are running by some XYZ user like Mike, you can use the command called as ps-u root, which is going to show you all the process that are running by this particular user root. For example, if you see ps-u CentOS, it's going to show all the process that is running by this specific user. Now I'll execute one command, sleep. Sleep is a command which gives, which pauses, okay, which literally sleeps for 10 seconds. But I would like to run this command in the backend. That means I would like to run this job as a backend job. You can use at the end symbol. It's also called as ampersand. Enter. Now if you type ps-ef ps-u CentOS, now you can see sleep command is executed. Okay, this is how you can see the list of all the process that are running by a specific user. All right, so that's in the today's session. In the upcoming session, I'm going to teach about how to edit a file and how to search and replace entries in file. Basically, I'm going to talk about editors in Linux, which is very, very, very important in Linux. So please ensure you watch the next video. And if you like the content, please ensure you subscribe to our channel. This motivates us further. And if you like the content, please like and please subscribe to the channel. This helps us motivate further. Thank you. I hope you like the content. I'll see you in the upcoming session. Thank you. Signing off.